All right, last time we went over how to graph an exponential function. Now we're going to be looking at graphs of exponential functions and writing those equations down. All right, so when writing an exponential function, you must ask yourself these following questions. Is it linear or exponential? That's important because if it's linear, that's a very different equation than exponential. Is it increasing or decreasing? In other words, from left to right, is it going up or down? That matters. And what is the constant difference that's linear only, or ratio, or the thing that you're multiplying by every single time? All right? Okay. So when writing an equation for exponential, we end up with y equals r. This is what we're multiplying by every time, to the x plus our asymptote. R stands for ratio. So let's go ahead and see what happens here. So first things first. So we're going to end up writing our equation. We already know it's going to start with y equals or f of x, and we'll get into that later. That'll be good. Okay, so y equals. Now, is this linear or exponential? This is solidly exponential. It is not a straight line at all. That's just, it's not. From left to right, and this is my favorite way to figure this out. So I start at my left point and I go to my right point. Did I go up or down? I went up. So that was increasing, which means we're going to have a ratio, and this is where we have to figure it out. So I like to draw a little highlighted line at my asymptote, and I count up how far from the asymptote I am. So that's 1, and this is 1, 2, 3, 4. And then this next one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we went from 1 to 4 to 16. We're multiplying by 4 every time because we're multiplying. Okay. My domain of this function, rather boring. It's negative infinity to infinity. Okay, and where's my asymptote here? My asymptote's at 0. So my range, and it's pointing up, so my range is going to be from 0 to infinity. Now, we're multiplying by 4 every single time, so we're going to have 4 to the x. And my asymptote this particular time happens to be at 0. So I'm going to put plus 0 to remind myself that I need to put the plus for the asymptote right there. Okay? All right. Let's take a look at this one. Is this linear or exponential? Hopefully you all said exponential. Is it increasing or decreasing? This is where I use my pen. I go from the left side, I go to the right side. Ooh, that went down. That's decreasing. Okay, if it's exponential, we have a ratio. This is where I draw my line for my asymptote, and I start counting. So that's 1 above, that's 1, 2 above, that's 1, 2, 3, 4 above, that's 8 above. So this goes 8, 4, 2, 1. Each time I'm dividing by 2. So my ratio is 1/2. Okay? And my domain, negative infinity to infinity. Very, very boring. However, my range is from 0, because if I squish it all together, I never reach 0. Notice that this number is always my asymptote. Okay? 0 to infinity. Beautiful. All right, so we have y equals, we're dividing by 2 every single time, so I'm going to do 1/2 to the x. And this is where normally I would put my asymptote, but because it's 0, we just put plus 0. You might come up with an asymptote later. Go ahead and try this one. So, see if you can figure out what's happening every single time. Increasing, decreasing, linear, or exponential. Does it have a difference or a ratio? If it has a ratio, is it dividing or is it multiplying? If it's dividing, remember to write it as a fraction. And then once you finish with that, we will meet back together on this page.